quadratic functions and graphs. We will be working with quadratic functions that are of this form, ax squared plus bx plus c. And today's goal is how to change them to this vertex form. We'll talk a little bit more about what that means. But before we begin, let's think about this word quadratic function. See, words are as important as equations in math. Some people have the wrong idea that math is just about equations and words don't mean anything, but you do need to know the terminology. So who can tell me what this quadratic means? What does that mean, quadratic? Yeah?
It's got 4 variables.
No? Yes?
Is it like the x squared? It's like the format's like x squared.
X squared, yes. Anything that has x squared. So the thing that puzzles some people is that it has this word quad. What does quad mean? 4, right? But this is 2, x squared, right? Why do you use quad for what is x squared? And the problem happens because in Latin, quad has the meaning that it's 4, but also something that has 4 corners. Like, have you heard of some buildings called as quad, especially military quad, meaning military building because it has like rectangular 4 corners? So in Latin, not only quad has the meaning of 4, but it also has the meaning of square. And if you think about it, how do you read this? You read this as x squared, right? So when you say quadratic function, it's a function where the leading term is a squared, x squared. So if you have the highest order term as x squared, that's called a quadratic function. If it has x cubed or x to the fourth, then even if it has an x squared, it's not a quadratic function because it's like if you have x cubed, that's a cubic function. X to the fourth power, I don't know what that's called. Yeah, so there's other functions with higher powers, but quadratic is when x squared is the highest order. Okay, so hopefully that clears up what I mean when I say quadratic. The quadratic equations, quadratic functions, quadratic formula, all of these have to do with this one, ax squared plus bx plus c. Now, before trying to explain what this second one is, let's actually jump ahead and try to solve a question. And within context of this question, I'll try to explain what this second formula of the vertex form means, okay? All right, so let's say find intercepts and the coordinates of the vertex of y equals to x squared plus 4x plus 3 and sketch the graph. Okay, so let's try out this question. First of all, how do you find the y-intercept? How do you find the y-intercept? Set x equal to 0. Yeah, you set x equal to 0. So if you set x equal to 0 in this formula, you get y equals to 0 squared plus 4 times 0 plus 3. So that's equal to 3. So that's the y-intercept. Y-intercept is 3. How do you get the x-intercept? Yes, you set y equals to 0, which means now you have in the y equals x squared plus 4x plus 3, you have 0 equals to x squared plus 4x plus 3. And if you factor this, well, there are two ways to solve, or three ways. You can either complete the square, you can use the quadratic formula, or you could also factor. But when factoring is easy, that's the easiest one to use. So let's think about this factoring. The right side factors as x plus 3 times x plus 1, because 3 times 1 is 3, 3 plus 1 is 4. So when you factor a quadratic function with a leading term, just x squared, if it has 1 as the coefficient, then you just need two numbers that add up to the middle number and multiply to the last one, right? And those two numbers are 3 and 1. So 3 times 1 is 3, 3 plus 1 is 4. That's what you get. And therefore, you get x plus 3 equals to 0, which gives you x equals to negative 3. X plus 1 equals to 0, which gives you x equals to negative 1. How many points do you need in order to determine a straight line? 2 points will give you one straight line, right? It will determine the straight line. How many points do you need to determine a parabola? 3. If you know that the parabola has the axis of symmetry parallel to the y-axis, if it has a vertical axis of symmetry, then all you need to know is 3 points. There's one unique parabola passing through it. The proof is a bit more technical, so I'm not going to elaborate why. But since we have 3 and negative 3 and negative 1, 3 points, that already allows us to draw the graph. So let's try to draw the graph to see what's going on. Okay, so you have 1, 2, 3, and then 1, 2, 3. This will be negative 3, this will be negative 1. And because 3 is the y-intercept, you mark 3 on the y-axis. Y-intercept means that the graph passes through the y-axis at that exact point, right? And then x-intercepts are negative 3 and negative 1. So I marked it on the x-axis. Now we just have to draw a graph passing through those 3 points. That's a parabola. And the only way you can have a parabola passing through all of them would be this one, right? That would be the parabola. You can't think of anything else. Agreed? Okay. So that part we're done so far. We found the intercepts. We drew the graph. What's missing? Huh? What did you say? Yeah, we need the coordinates of the vertex. Okay, we need the coordinates of the vertex. What's a vertex? Yeah.
Where it goes from going down to going up.
Yeah, it's a turning point where it changes from going down to going up, right? Goes down until this point, and then it goes up again. Okay. Or if you have something negative in front of x squared, then in that case, your graph could be like this. So ax squared plus bx plus c would either be like this one or that one, depending on whether a is positive or a is negative. If a is negative, you have an upside down parabola. In either case, this point right here, these points are called the vertex. Now, other graphs have something like a vertex. If you have like a cubic curve, you might have a point like that. These points are just called turning points. Now, parabola has just one turning point, right? That's called the vertex. The vertex is the name for the unique turning point you have when you draw the graph of a quadratic function, okay? All right. Now, another thing that you should know is that when it comes to a quadratic function's graph, when you have a parabola that's ax squared plus bx plus c, these functions have something called the axis of symmetry. Axis of symmetry. And this one is called the axis of symmetry because if you drew this graph carefully and you fold it along this line, then the left and right side would match. Okay? It matches. So that's why it's called axis of symmetry. And axis of symmetry will pass through the vertex. That's the important thing. Okay, so with all this knowledge, can you tell me the x-coordinate of the vertex from this picture? Just look at the picture, tell me the x-coordinate of the vertex. -2. Actually, you guessed the y-coordinate is correctly as well. It's -1, okay? So you see that the axis of symmetry would be at x equals to -2. That would be the axis of symmetry because, if you say x equals to a number, that gives you a vertical line, right? The vertical line that would be the symmetry for this parabola would be x equals to -2. So that the vertex will have -2 as the x-coordinate. If you know the x-coordinate, how do you find the y-coordinate? No, it has nothing to do with the slope. Yes. You plug it in. And this is in general true. Whenever you're given a graph of a function and you know the x-coordinate and all you have to do is find the y-coordinate, you just plug in the x-coordinate into the function. That gives you the y-coordinate. Is that clear? That's not just limited to quadratic functions. It's true in general. In any case, if you know the x-coordinate and the goal is to find the y-coordinate, just plug in the x-coordinate into the function. So let's do that. Since we know that x equals to -2 is the coordinate of the vertex, we see that y would equals to -2 squared plus 4 times -2 plus 3, which is negative square is to positive, so it's 4. 4 times -2 is -8 plus 3. That's going to be -1. Therefore, this vertex is actually at -1. So this point right here is -2 comma -1. Those are the coordinates of the vertex. Now, I want to show you how to turn this equation, this given equation, to this second thing called the vertex form. So let me do some calculations here. Note, if you had y equals to x squared plus 4x plus 3, you can do completing the square to change it to the vertex form as follows. If you have y minus 3 equals to x squared plus 4x. So I first move the 3 to the other side. And now you have x squared plus 4x, right? What should I add to both sides so that the right side is completed as a square? 4. Where do you get 4 from? Half of 4, which is 2. You square the 2, you get 4. So you're adding 4 both sides. And if you factor this, sure enough, it's x plus 2 times x plus 2. So the right side is x plus 2 squared. And then 4 minus 3 is 1. So you get y plus 1 equals to x plus 2 squared. And then if you solve for y, you get x plus 2 squared minus 1. Now, this is indeed the vertex form. Since it doesn't look quite like this one, let me try to rewrite this in the following form. I want to write it as 1 times x minus -2 squared minus 1. Now compare this with this vertex form and tell me what A is. Compare this with this. Okay? A is 1, right? A is 1. What's H? H is negative 2. X minus H. That's what that says, right? And in place of H, you have negative 2. So H is negative 2. And then what's K? K is negative 1. Yeah, so all I did was I wrote this in this form. And these are the same, right? 1 times doesn't do anything. Minus minus is plus. So indeed, this is the same as that. These are exactly the same. Do you agree? Right? And if you write in this format, you see that A is 1, H is negative 2, K is negative 1. Now, what this A does is when we work with transformations, we learned that if A is big, then the graphs get squashed in the x direction. Or another way to say it is like it gets elongated in the y direction. So either way, when you take a parabola, if you take a parabola and squash it this way or elongate it in this way, you will get a parabola that's thinner, right? So the bigger this A is, it gets thinner. The closer this A is to 0, say like 1/4 or 1 over some really big number, then you get a very wide parabola. That's what this A does. On the other hand, this H and K does the shifting, right? That's how we learn from the parabolas. See, if you had y equals to x squared, and if you moved this negative 2 steps or 2 steps to the left and down by 1, you get exactly this one. This plus 2 moves this graph which direction? 2 to the left, right? What does this one do? Goes down by 1. So if the original y equals x squared has the vertex at 0, 0, if you move this 2 steps left and 1 step down, you do get this new vertex as negative 2, negative 1, as you would expect. All right? So from that perspective, it's kind of natural that this value of h and k should tell you where the vertex of y equals x squared moved. Originally, when there was no translation up and down, it was at 0, 0. And since it moved by h and k, the new vertex will be negative 2, negative 1. All right? So this immediately tells us that when you have a vertex form, for this vertex form, h, k is the vertex. Now here's another way to look at the same formula. It's good to have many different ways to understand the same formula. So let's revisit this and pose the following question. What's the minimum value of this function? What's the minimum value of this function? Well, when x is negative 2, it will attain negative 1, and you can't go lower than that. Do you agree? Right. And the reason is square can never be negative. So this is the least value for this function is 0. Therefore, when you subtract 1, the least value you can have is negative 1. So negative 1 is the least value that this function can produce. Also, the negative 1 happens when x is negative 2, because negative 2 plus 2 gives you 0. And that's plainly obvious from this function, right? This graph. This graph says that the lowest point on the graph is this negative 2, negative 1, right? Negative 1 is the least value that this function can produce. So that's another way to look at this formula here. See, if a is positive, then the least value this can have is k. When does that k happen? When x is equal to h. If x is also h, h minus h is 0, and the y value becomes k. And that's why h, k is the vertex. That's one way, another way to understand it. Okay? So there's two different ways of understanding the vertex formula. is something that you should know. One is to think about this as like shifting h to the right and k up. Therefore, h comma k is the new vertex. That's why h comma k is the vertex. Another way to understand this is when x is equal to h, you get the minimum value of k. That's why h comma k is the vertex. Those are the two different ways to understand this. Okay, now let me pose another question. How do you turn a given equation to a vertex form? Okay, all right. How do you find the vertex? We did it in two different ways. Okay, one was what did we do over here? Completing the square, right? We completed the square to find the -2 comma -1. Okay? That was one method. How did we find -2 comma -1 in this problem? Yeah, we were using axis of symmetry. We are using the fact that axis of symmetry is exactly the symmetry line of a problem. And using that, we are able to identify that -2 should be the axis of symmetry. Why? Because you have two x-intercepts, -1 and -3. What's the average of -1 and -3? Midpoint is -2, right? Do you agree? So there are two ways to find the vertex. One is to use the completing the square. The other is to uh, find the midpoint of the two x-intercepts, because that gives you the x-coordinate of the vertex. And once you find the x-coordinate, how do you get the y-coordinate? You plug it into the function to get the y-coordinate, okay? And now usually completing a square is hard. Don't you agree? Yeah? Who thinks completing a square is really easy? You think so? You think it's easy? Okay. Who thinks it's really hard? It's kind of annoying and hard, right? So what we're going to do is we're not going to use completing the square, but instead we will always try to use this method of finding the midpoint of the x-intercepts. For this function, how do you find the x-intercepts? Satisfy what? Not x equal to y equal to 0. So this is y, so you can set y equal to 0. So the x-intercepts are the x values that satisfy this equation. And you all know the formula for this, right? How do you find the x value for this equation? Plus minus square root of b squared minus 4ac over 2a. Now you can rewrite this as two solutions. One solution is x equals to, oh sorry, there's a minus, I forgot. X equals to negative b over 2a plus square root of b squared minus 4ac over 2a. That's one solution. What's the other solution? X equals to negative b over 2a minus square root of b squared minus 4ac over 2a. These are the two solutions, right? All I did was I just rewrote this into two fractions. Right? Yeah, I'm just rewriting it. Okay. Now the question is, what's the midpoint of these 2 points? Now to help you out with this, let's ditch this for a while. Let me ask you some really simple question. Okay. So the really simple question is, give me the midpoints. So A, if you had 3 plus 1 and 3 minus 1, what's the midpoint? What's the midpoint of 3 plus 1 and 3 minus 1? 3, right? Okay. What's the midpoint of, say, 27 plus 19 and 27 minus 19? 27. Is that clear? Do you need some explanation of why, or is this okay? Not if you understood. Okay, if you didn't understand, do this. Okay, some people are doing that, so let me try to explain. So if you put these on the number line, here's 27, and then if you add 19, this point will be 27 plus 19. Yes? And if you subtract 19, this point will be 27 minus 19. Yes? Okay, so what's the midpoint of these two? 27, right? It's right in the middle. If you're at this point, you go right and left by the same amount, then this will be right at the center. Is that good? Now, is there anyone who don't understand? Who doesn't understand? Everyone understands? Not if you understood? Okay, good. All right. So that's what it is. All right. C, what's the midpoint of, say, 3 plus square root of 7 and 3 minus square root of 7? What's the midpoint? It would still be 3, right? Good. Now, what's the midpoint of these two? See, one, I don't really care what this is. It looks very scary, but it's just some number that's added and subtracted. The same thing is added, same thing is subtracted, right? So even if I have no understanding of what this quantity is, it's the same thing added and subtracted. Therefore, the midpoint will be exactly right here. Okay? So, out of this, here's a nice conclusion to the discussion we just had, which is that the x-coordinate of the vertex, this right here, h is the x-coordinate of the vertex, has the formula h equals to negative b over 2a. Now, where does this formula come from? It comes from the quadratic formula. It's basically taking the quadratic formula and ignoring the square root part, only taking this much. That's where negative b over 2a comes from. And that means, you know how we sang a song about the quadratic formula, right? X equals to negative b plus or minus square root b squared minus 4ac all over 2a, right? In this song, all you have to remember for this new formula is just don't sing this part. So it will be like x equals to negative b all over 2a. You just ignore this other part, and that's the formula for this one, negative b over 2a. You get me? Okay, hopefully nobody's going to forget that. Okay, good. Now, once you find the x-coordinate of the vertex, there are two things to do here. One is the axis of symmetry will now be x equals to h. Once you get this formula, yeah, or maybe I should just write it like this. And because it's a vertical line, this is part of the answer. If you just write this, that's not the axis of symmetry. You have to say x equals to something. Okay, and then secondly, to get the k, which is the y-coordinate of the vertex, this will be, you plug into the function the h. That's how you get the k value. Okay, with this knowledge, let's try to do the second question. All right, try this question. Let's try this question together first, okay? And I'll give you in the next example, hopefully by then you're going to understand what we're doing. Okay. So first of all, how do you get the y-intercept? To get the y-intercept, what do? Set x equal to 0, yes. So the y-intercept you obtain by plugging in 0 into f. That gives you negative 11. And then the vertex, how do you get h? What's the formula? Negative b over 2a. That's it, yeah. Yeah. It's part of the quadratic formula song, right? What is b? This one, 6, right? It's a, b, c, so b is 6. What's a? Negative 1. So what do you get? Positive 3. You get h has positive 3. How do you get k? You plug 3 into the function, right? So f of 3, which is negative 3 squared plus 6x, 6 times 3, and then minus 11. Now here's a common mistake. Many people think negative 3 squared is positive 9. That's wrong. That's wrong because negative is on the outside. You should really think of negative 3 squared as negative 1 times 3 squared. And because of PEMDAS, you'll know PEMDAS, right? Exponents takes precedence over multiplication. So you have 3 squared first, which is 9, and then you have 9 times negative 1, which is negative 9. You have a question? There's a minus here, and there's another minus here. Minus, minus cancel, so it's positive 3. Okay. Okay, so in other words, what I'm trying to say is that negative 3 squared is not the same as negative 3 parenthesis squared. Here, negative is also squared as well. In this case, it will be positive 9. Here, negative is outside the squared, so you have 3 squared, which is done first, which is 9, and then there's a minus attached afterwards. Okay? Yes? Where do I get, oh, this negative one? I'm just rewriting negative. Negative of any number is same as negative 1 times that number, right? Oh, this negative one, that negative one is from this negative one. When you have A, B, C, A is negative 1, B is 6, and B is 6, and C is negative 11. Okay. All right, so I took a long time explaining that this is negative 9. Hopefully I don't see that mistake when I walk around. It's going to be negative 9 plus 18 minus 11. 18 minus 11 is 7, so negative 9 plus 7 is negative 2. So 3 comma negative 2 is the vertex. Okay, so let's see. You have 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Negative 11 is the y-intercept. 3 comma negative 2 is the vertex. Now, at the vertex, either the graph is like this or that, right? Which one are we working with? Opening down or opening up? Opening down. Why do we know that? Because the coefficient of x squared is negative. If this is negative, the parabola opens down, okay? So I know that from the vertex, the parabola opens down, okay? And it has to pass through this point, so it must be going this way. And because this is part of the axis of symmetry, the other part should be like that, okay? Yeah, okay. It's not pointed, it should be like round. Yeah. That's the parabola. Okay, so that's the graph. Finally, what is the axis of symmetry? It's this vertical line, right? What's the equation for this vertical line? X equals to 3. Yeah. Vertical lines have the form x equals a number, right? So this is the axis of symmetry. Axis of symmetry is x equals to 3 because it's the vertical line passing through 3. So x value is 3. Yes?
Why would that be a positive?
What? I do have positive 3. Why? Oh, negative 3 squared is negative 9, not positive 9. Yeah, I spent some time trying to explain exactly that. Okay, it's negative 9. This negative is after squared. Squared is to be done first. So you should be able to distinguish between negative 3 squared and negative 3 squared. These are different, okay? Yeah. Don't confuse them. Okay, so since I've shown you this one, hopefully you can do the next one by yourselves. Well, we'll do the exact same question, but then this time it will be f of x equals to negative 2x squared plus 8x minus 9. Try that. All right, first, y-intercept, you set x as 0. That gives you f of 0 equals to negative 2 times 0 squared plus 8 times 0 minus 9, which is equal to negative 9. Okay. And then for the h, this is negative b over 2a. What's the value of b? A, right? It's a, b, c. So a is negative 2, b is 8, c is negative 9. So b is going to be 8, a is going to be negative 2. Now notice that there's a minus here, there's another minus here, so they're going to cancel. So what do you get? 8 over 4, which is equal to 2. Right? 2 times 2 is 4. So that gives you 2 as your x-coordinate of the vertex. How do you get the y-coordinate? You plug in the positive 2 into the function. So that's going to be negative 2 times 2 squared plus 8 times 2 minus 9. And it's a good idea to always use a parenthesis when you're plugging in. Okay? That helps you to avoid any mistake. So here, this 2 is only affecting this 2. This 2 doesn't do anything to this one. Okay? It's only doing to this one. Okay? And because of PEMDAS, exponents should be done before multiplication. So this has to be done first, which is 4. 8 times 2 is 16. Negative 2 times 4 is negative 8. Plus 16 minus 9. What's 16 minus 9? Positive 7. So negative 8 plus 7 is negative 1. And therefore, 2 comma negative 1 is the vertex. Now we are ready to draw the graph. 1, 2, negative 1. That's the vertex. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's negative 9. Here's the point. And then at the vertex, it's either this way or that way. Which one is it? Opening down or opening up? Down, because it's negative in front of x squared. So you have the graph opening down. It has to pass through this point, so it must be like that. Okay, so that's the graph. What's the equation for the axis of symmetry? Axis of symmetry is x equals to 2. It's important that you write down x equals. If you just say 2, that's wrong. Axis of symmetry is not 2, but it's a vertical line, and the line has the equation x equals to 2. Okay, that's all for today.